Hey guys, this is salamanderanagram, and welcome back to our series on building chord generators in Reaktor. In this video, I'll show you how to add snapshot capabilities to this project so that you can save your work and load it again later. Right now, all your work is just deleted whenever Reaktor is closed. So the first thing I'm going to do is create a new macro, and we're not going to have any visible elements inside, so I'll go to the View tab of Properties and turn the Visible property off. And I want to save all of the data that's being used to control our event table, so I'm going to take the X, the Y, and the value outputs from the core cell, and I'll use them to create new inputs to our macro. And I'll use these to control a snap value array, which is going to hold all of our data. And there's a few things we want to change here. First of all, set the default value to 0. That's the first thing to do. If you do it after you change the array size, you'll regret it later. Next, you can change the array size to 144 and turn the write through value off. So a snap value with the write through value turned off does one thing, which is to store the data that you have sent to it, and then it recalls that data when a new snapshot event arrives. At all other times, any data arriving does not cause an output to the snap value array. So we can send our value to the right input of the snap value. And then we want to use the X and the Y to calculate the index, just like we did in the core cell. So we'll take Y, multiply it times 12, and then add X. And that's going to give us a value ranging from 0 to 143. And our snap value array, this primary array here, works a little bit differently than the core array in that the indexing starts with a value of 1. So whereas the core cell wants a value from 0 to 143, the snap value actually wants a value from 1 to 144. So we'll just take this and add 1 to it. This is one of my biggest pet peeves about Reaktor, that the indexing systems are different for different modules. It's pretty frustrating and kind of bad design in my opinion. Alright, so then we'll take the index coming out of the snap value, and because it's 1 too high for the core value to use, then the core cell to use, we'll subtract 1 from it. So now this ranges from 0 to 143 again. That's going to be an index value. And then we will connect the output to the core cell as well. Both of these outputs from our macro will be connected to our core cell. So basically here we're just taking the outputs from the core cell and storing them, and then when we want them later they can be recalled by a snapshot. So create new inputs for the core cell and wire everything up. Looks like we're getting an error here. That's because we're using a bunch of polyphonic modules. So let's just set this whole bunch of stuff here to mono. Everything but the MIDI macro and the event table and the stuff connected to the MIDI macro basically. Alright, so let's create some quick buses for our new inputs. And we'll use the index value to control our array. We'll rename this init index for the initialize index. And I want to create a new write macro to our array. And it's going to receive the incoming value and initialize index. So all of our data is being read from the snap value into our array whenever a new snapshot is recalled. And next I just want to take this data and use it to draw onto the event table. So we have our data inside the core cell array now, but we want to also have it feed into the event table. So in order to do that, I'm going to take our initial index value here, and I'm going to break it down into its composite x and y values. And in order to do that, I'll use a div mod macro, which is identical in functionality to the primary modulo, except that it only works on integers. So we'll do a modulo by 12, and the div output here is going to be our y value. So we'll name this initialize y, and the mod output will be our initialize x value. And this basically undoes the operation that we did earlier where we multiplied y by 12 and then added x to it. This just takes that value and gives us back our original x and y values. So now we have these new values when we are initializing, and we'll just merge the original x quick bus here with the initialize x. We'll do the same thing with the y's. And when we're done with this, we'll do the same thing with the value output. So this just allows you to store your data and recall it at will using snapshots. This is incredibly important for projects like this because setting up this whole matrix of chord values is pretty tedious. Alright, so you see how we've got these two guys lit up at the top here. That's because the snapshot value initially had two components, and the default was initially 0.5. So if we had changed the size of that array to 144 and then changed the default value to 0, then the whole snapshot value would have been initialized to have a default value of 0.5, and you'd have to turn them off one by one. So thankfully we only have to fix the two that got broken, and at this point in time everything should work. So here I've got a C major chord, and I'll just save that as a snapshot named C major, and then I'll change it to a C minor and create a new snapshot for that, and you'll see we can toggle between them effortlessly. So now we can create more complex setups and recall them at will. Alright, once again, this is Salamander Anagram. Thank you guys for watching.